in the College of Ag and Human Sciences at Prairie A&M University. Before joining us in July of this year, Dr. Dhoudhadel served as an assistant professor of agribusiness at Fort Hays State University in Kansas. He holds an MS degree from Texas A&M University and a PhD from the University of Nebraska-Lincoln in agricultural economics. His research focus area is in the economics of crops and livestock production, agricultural markets, and trade. Sunil has published research articles on the analysis of U.S. biofuels policy and drought impacts, U.S. beef trade, biofuels trade, profitability of beef production systems, and the impact of livestock production on land use changes and greenhouse gas emissions. So with that, I invite Sunil to the podium to present to the group. Thank you.
Thank you, Dr. Kwaku. I just want to make sure that all of you can hear me. Is it fine, my voice? Okay. So before I start my presentation, I would like to first acknowledge my co-authors of this paper, Dr. Azzeddine Azzam and Dr. Matt Stockton, both from University of Nebraska-Lincoln. So as the title suggests that there is a relationship between agriculture markets, biofuels, and drought. So for us, I mean, it's obvious that drought will have implications or impact on agriculture markets, but for some, the relationship between biofuels and agriculture market may not be that obvious. So I would like to spend a little bit of time on that first. So the relationship comes through this commodity called corn, right? Corn is input for both biofuel production, corn ethanol, and livestock production. So if we look at this chart over here, we can see the use of corn for corn ethanol and livestock production over the years. So if you look at here, in 1980s, there was not much of corn used for ethanol production, but especially after 2005 and 7, it's kind of exploded. So this is corn used for ethanol production. So in 2018, the proportion of total corn used in the United States, about 45% of that is for ethanol production, and about the same proportion is used in for livestock production, and rest is for the other uses. So we can see here that for corn produced in the United States, both livestock and biofuel industry compete for that corn produced here in the United States. So whatever happens because of this kind of integration in agriculture market, biofuels, whatever happens in in ethanol production has implications for livestock or for agriculture. So because of that, what we saw is that because of that increased use of corn in livestock production, ethanol production, the corn prices over the years have dramatically increased. So if we look at the ethanol production here from 2007, 5 and 7, the ethanol production has dramatically increased. So if you look at here, there's this steep slope for this graph for both for production and consumption. So it has quite skyrocketed. So it had implications for the corn market. So especially during that time period, I remember that around in 2000, the corn prices were about $2. So around 2007, it increased to about $5 per bushel. And it peaked at about $6, $7 by 2012, 2030. So that was the peak. So what drove that increase in ethanol production in the United States? So there was this policy called renewable fuel standards, okay? So it was introduced first in 2005, and then in 2007, this policy was introduced. And what this policy required is that the fuel industry should consume about fixed quantities, volumes of ethanol. So it included the mandate required that the fuel industry mix a certain portion of ethanol with gasoline. So, for example, currently we are consuming about 15 billion gallons of gasoline in the United States per year. So about 10% of that means about 15 billion gallons, has to be mixed with gasoline. That's by law. Not only that, the renewable fuel standards, that biofuel policy mandates that we consume certain volumes of biodiesel, cellulosic ethanol, and certain portion of advanced biofuels, which are the biodiesel and cellulosic ethanol are also considered advanced biofuels. On top of that, we import some ethanol, which is sugarcane ethanol from Brazil. That is also considered as advanced biofuel. So if we look at this RFS mandate chart here, what we see here is that in the initial years of that policy, the mandate was just for corn ethanol, the ethanol produced in the United States, mainly from corn. That was the mandate. That mandate slowly increased, and it reached up to 15 billion gallons by 2015. And when drought happened in 2012, the mandate was about 13.6 billion gallons. So in this chart, we can also see that after 2015, that corn ethanol mandate stays the same. So it is 15 gallons up to 2020, but the proportion of other advanced mandates, cellulosic ethanol, biodiesel, other advanced biofuels such as sugarcane ethanol, the proportion of that increases. And by the end of this envisaged timeline, we'll have about 15 billion gallons of ethanol consumption and about 21 billion gallons of advanced biofuels consumption in this country. So that's required by the law. So with this policy background, there was this drought in 2012. So when this drought happened, it was a severe drought. It affected most part of our country. So when that happened, there was this call for mandate waiver. Many states, especially livestock producing states, they called for this mandate waiver. They asked that this mandate at least needs to be partially waived, if not fully waived. So that was the call. But at that time, it was not clear how that mandate waiver would be helpful to the agricultural markets. It was not clear. And to what extent that mandate waiver has to be provided in order to provide mitigating effect to the agricultural market. Some preliminary studies were conducted, but it was not that conclusive. Now, given that drought is kind of a recurring phenomenon, given the climate change situation, we have frequent droughts, not only in this country, all over the world, this question is still relevant, whether we can use a policy tool like biofuel mandate waiver to mitigate the impact of supply shocks such as drought. So that's what this study is focused on. So basically, at that time, the EPA, Environmental Protection Agency, had two policy options. One is to go for partial mandate waiver. What does that mean is to write down some portion of mandate for that year. So for example, it was 13.6 billion gallons for that year, so they could reduce some of that mandate by writing a rule that for that particular year, they don't need to blend full 13.6 billion gallons. The other option that is inbuilt in the policy itself is called RIN credit. Okay, so EPA could have ensured that the available RIN credit in the market is fully exhausted. At that time, about 2 billion gallons of RIN credits were available in the market, and if they ensure that all of those RIN credits are exhausted, then that would have been equivalent to this partial mandate waiver. Now the question comes, what is a RIN credit? So a RIN credit is a credit given by the EPA to those gasoline or ethanol blenders for blending each gallon of ethanol with gasoline. So if they blend 2 billion gallons, they get 2 billion RIN credits. So the beauty of this RIN credit is that, so if somebody, so by law, they are given certain target to blend ethanol with gasoline. So if somebody, let's say, for some year, they blend more than what is required by the law for that year, they could bank that RIN credit and use it when they want to blend less than what is required by the mandate. So that mechanism is already built in. So in difficult time like this, EPA could ensure that all of the RIN credits available in the market is exhausted so that it would be similar to giving a partial mandate waiver. So that's first policy option. The second policy option would be to go for full mitigation option. What does that mean is that EPA set their mandate to that level that would fully offset the increase in corn prices, because as I have just discussed before, ethanol is basically, in the United States, ethanol is basically produced using corn. So they could set the mandate at that level that would fully offset the impact of that drought on corn prices. So keeping those two policies in mind, we basically analyze those two policy options. So first, we look at the question, what would be the difference in drought impact if by using the available RIN credit in the market, what would be the difference in impact of drought with and without RIN credits? That was the first research question we tried to answer with this research. And the second question is related to that full mitigation option that require estimating what would be the mandate requirement, or what would be the mandate waiver requirement that would fully offset the impact of drought on corn prices. So basically, what we are trying to figure out here is that, is this RFS mandate waiver, is it really a viable policy during this supply shocks such as drought to provide relief to the agriculture markets? Yes, please. Yes. Actually, you can buy RIN credits from the market. So the basic idea is to the basic idea is the consumption of certain volume of ethanol in the market. So if you buy RIN credit from others, you can use that RIN credit as an evidence that you have blended this many volume of ethanol. So there is a market for RIN credits also. So there is always price fluctuation depending on this mandate also, that requirement of RIN credit varies in the market. So basically, we looked at 8 agricultural markets. Those are grain markets such as corn, soybean and soybean meal, distillers grain, ethanol market, and in terms of livestock market, we looked at the impact on beef, pork, and poultry market. And especially for those meat markets, we looked at impact not only at the retail level, but also impact at the food marketing chain. For example, impact on the farm, processing, wholesaling, and retail level. So we built in that all those marketing chain in our model. So generally, what we see is that when we have these kind of marketing impact evaluation studies, those impacts are presented as point estimates, meaning that, let's say, the study will predict that the price of corn will increase by 5%, just the point estimate. But in this study, we have gone beyond that. We have kind of developed a confidence interval following this technique called Monte Carlo simulation. We formed a distribution of those impacts so that we can have, we can attach probability of those impacts. So that's something that we added for the study. So I would like to briefly explain how the model works. The model is called equilibrium displacement model. I don't want to go very technical on this model, but I just want to simply describe how the model works. So what we have here in real life, whenever I teach in the class, I always try to relate real life with what I'm teaching. So that's actually the model also mimics that. Before drought, we have market equilibrium, right? There is equilibrium price, equilibrium quantities for all those commodities that we are analyzing. So it's an equilibrium situation. So when drought happens, it gives shock to that system, and then that system is disturbed, and then we'll have new prices and new equilibrium quantities in the market. So using this equilibrium displacement model, actually we just mimic that process. But when we do mimicking, it's based on demand and supply equations. So what we did is that we first specified pre-drought equilibrium situation using all these demand and supply equations. So there would be a system of demand and supply equation, and then to that system, we give this external shock as drought, and then that system disturbs, and again, it solves for new equilibrium. So when I say new equilibrium, I just want to be very clear is that we are trying to figure out after drought, what would be the prices, especially we are interested in prices and the equilibrium quantities, change in prices and equilibrium quantities for those 8 markets. So just want to give you a flavor of what kind of equation I'm talking about. I have specified equations for all those markets. For example, for this meat market, I'm just showing for the meat market. Like I said, we specified all those demand and supply equations for retail, processing, the feedlot level, and the farm level. So that becomes a system of equations for beef market. So similarly, we have systems of equations for corn market, for poultry, for pork, and all those systems are tied together. So basically, mathematically, you can represent that whole system as this A. A is a matrix of because in those equations, there are coefficients which are, in economics, we call it elasticities, those coefficients. So A matrix is the coefficients of elasticities. X is it is called endogenous variable in the model, meaning that we are trying to figure out what would be the prices and quantities of those commodities in those markets. So X represents those vector of those endogenous variable, and B represents the vector of exogenous variables. And so when you invert that A matrix, we get the answer. So this is a kind of a summarized version of how the model works. So I don't want to bore you all explaining all this technical details. So I would like to directly go to the results that we obtained. So mainly because prices are the most interesting thing that we want to study. So in this presentation, I have just included our results for prices. But given the time limitation, we do have results for quantities also. But here I'm just presenting the impact on prices. Okay. So if we look at this slide here, after drought, so this is without use of any policy intervention, meaning that we have not used any RIN credits. What will happen to the market if drought happens? So we see here that there is a considerable impact of drought on, especially on grain market. So among grain market also, we see greatest impact on corn market, because the corn market increases about 9%. Soybean and soybean meal also increases, but not as much as corn. So there is a considerable impact, and understandably so, because they are the primary recipients of drought. So understandably, they will have greater impact. And among the meat market, we can see here, there is also impact on the meat market. This is change in price at the retail level due to drought. We see that there is a considerable impact, especially for the beef market, while for the pork and poultry market, it's not, the impact is there, but it's not as much as in case of beef market. And the reason for that is that beef is affected in two ways. When drought happens, it is affected by increasing corn prices, so that will increase its feed cost. And at the same time, so for beef, another input of production is pasture. So pasture is also affected when drought happens. So when everything is taken into consideration, their marginal cost, we say marginal cost or cost of production, shifts, and that leads to increase in price. But compared to beef, pork and poultry, they are just affected through this grain market, increase in price of grain market. And even within that, there's a possibility of substituting some of those grains with cheaper alternatives. So we don't see that much of increased impact on pork and poultry. Now, let's look at how that increased price in the corn market or grain market affected feed demand. So we can see here is that there is a considerable decrease of demand for corn from beef sector, and export demand also decreases with drought. But from pork and poultry sector, there is not significant. It's not that 0% decrease, but it's not statistically significant. That's why I indicated there. There's no change in demand for corn from pork and poultry sector, but there is a considerable decrease in demand for corn from beef sector. Let's look at for the soybean meal. The story is kind of similar. Considerable decrease from beef sector, pork and poultry, almost no change. But for the distiller's grain, the story is different. There is a decrease from beef sector, but it's not as much as in case of corn and soybean meal. If you look at for the pork and poultry, actually with drought, the demand for distillers grain is actually has increased. So what this is suggesting is that when drought happens, corn prices increases because there is shift in supply. That makes corn relatively a expensive feed. So the livestock producer, they try to switch to the other cheaper alternative, which is distillers grain. So they are substituting distillers grain for corn. So that's what is happening with drought. Now let's look at, now if you remember, we are looking at two policy options. What will happen if those RIN credits that is available in the market is used to minimize the impact of drought? So with the use of RIN credit, so this maroon bars are impact without use of RIN credits. Blue are impacts with the use of RIN credit. With use of RIN credit, we see that there is a considerable mitigating effect, especially in case of corn. But in case of soybean meal and soybean, there is not much of effect, and understandably so. Why? Because with RIN, there will be less consumption of ethanol. That means less corn is used for ethanol production. That means there is a shift in, also some shift in supply for corn, and meaning that there is a release of demand pressure for corn from ethanol sector, so that helps to minimize that impact, even though there is, compared to pre-drought scenario, there is increase in price by 3%, but that increase is not as much as it would have been with the use of, without the use of RIN credit. So that's on corn. Like I said, there is not much of difference in case of soybean and soybean meal. And if you come to livestock market, there is also not much of a difference. What this is telling us is that even though there is some mitigating effect on corn market by decreasing corn prices, that effect is not transmitted through the marketing chain of those meat markets. Even though they are getting some relief in terms of reduced corn price, that is not transmitted up to the retail market. So we don't see that much of a difference in case of meat markets. There is a drastic decrease in ethanol price, understandably so, because that mandate waiver or partial mandate waiver reduces the demand for ethanol, and that is acting as, so that is the cause of a decrease in ethanol price. So how it translates into feed demand, if we look at here for the beef sector, even though with use of RIN credit, there is a decrease in demand for corn, that decrease is not as much as it would have been without the use of RIN credit. In case of pork and poultry sector, demand for corn actually increases. Previously, there was no change. If you look at here, there was not statistically, maybe probably even decrease in some cases, but statistically, it was showing up as no change in their demand. But with the use of RIN credit, that demand goes up for corn. And for ethanol, because RIN credit is used, less of ethanol is produced, and the demand from the ethanol sector also goes down. So that's for corn. For soybean and soybean meal, the story is different from RIN, no RIN scenario here. What we are seeing is that with use of RIN credits, the demand for soybean meal and distillers grain from beef sector goes further down. For pork and poultry, look at this is obvious here, is that before use of RIN credit, there was more demand. The increase in demand was higher than with use of RIN credit. So what it is telling is that with the use of RIN credit, as we have seen that there was drop in price, corn price, now reverse substitution is going on. Now those livestock producers, especially pork and poultry producers, they are switching back to corn because now corn becomes relatively cheaper compared to distressed grain with that relief provided. So that was the partial mitigation results on partial mitigation option. Now I would like to switch to the other policy option, which is to go for full mitigation option. So that required EPA to fix the mandate at that level that will fully take out that increase in price due to drought. So in our calculation, what we came up with is that EPA has to reduce about 23% of mandate. They have to waive about 23% of mandate for that year. That is equivalent to 3.12 billion gallons of ethanol mandate has to be waived if they want to fully mitigate the effect of drought on prices. So that means that there will be about decrease of about 13.6% decrease in ethanol consumption. That will release about 0.6 billion bushels of corn in the market. So that's how this full mitigation option works. Now, given these results, we have concluded some points here. So based on results, what we see is that there is a considerable impact of drought on agricultural markets, especially the impact is quite severe for corn market without use of any policy instruments. Among the meat markets, the highest impact that we saw is in case of beef. Why? Because there is a dual impact of beef during drought. It is impacted through the feed market as well as through the pasture. So that's why we see quite an increase in beef prices at the retail level. In case of feed, corn demand is the most affected because there is a drastic decrease in demand from beef sector. Now, in terms of that full mitigation option, 23% mitigation, 23% waiver is, quite a big waiver required. I don't know if that would be palatable to the EPA because it requires considerable write-down of mandate for that year. So it seems like this mandate waiver of 23% would be not that palatable for the Environmental Protection Agency if they want to fully mitigate the impact of drought. Use of RIN credits, the market mechanism provided by the biofuel policy, which can act as partial mandate waiver, it has some impact on markets, especially for the corn, but that impact is not fully transmitted to the other stakeholders in agriculture markets. So the question here, the more important question here, who would benefit from that kind of policy waiver provision? So if we ask beef producers or beef processors, certainly they would want that kind of at least some relief in corn prices, and that would translate into lower cost of production for them. But what we see is that, as we have seen on those charts, it's not transmitted to the consumers. So certainly consumers are not benefiting from that kind of policy. And if you ask corn producers, certainly they will oppose that kind of policy. And actually that's what happened, because when drought happens, they are losing all their production. Their yield decreases, and their only hope is to get higher price. When those who haven't lost all of their corn, they want to recover by getting those higher prices. So certainly they would oppose that kind of policy intervention. So depending on type of stakeholders in the market, the implications of those policy is different. So in summary, what we concluded is that even though there is some relief provided to the corn market, that mitigation impact is very limited. So it is limited to the corn market. It doesn't transmit through the livestock production system or market system, and doesn't provide that relief to the consumers. So probably that is the reason why the EPA didn't grant any mandate waiver for that year, even though there were many calls for mandate waiver from many states. EPA didn't grant any mandate waiver for that year. So that is all from my side. So if you have any question, please feel free to ask. Thank you. Yes, please.
Okay, good morning.
Morning.
So normally we see the drought in the climate cycle or climate scale. Like if we had 2011, maybe we can get 2021 or later. So do you have a similar study, or do you have planned for similar study to study the impact of flood?
I think we can incorporate actually in this model. So the model that we have built, this is called partial equilibrium model. Here, the assumption is that the other external factors such as trade, import, export, those other factors, given those stay as same, what will happen to the market? The flood actually can be included. So it's just the reverse of drought, right? So we can include that shock in the model itself, so we can see what the information that just we need is that what would be the extent of flooding. So that if we have that data, we can use the same model to figure out the impact of drought, impact of flood on the market also. Yes, please.
Using historical data, can you use these equations to evaluate the effect of the mandate itself, whether it's really effective or how that would change the prices?
You mean, so I think, definitely we can do. I mean, if we collect the data from the past, we can show that mandate as is another. This would be a shock to the system, how that would affect the outcome. Definitely that can be done.
We have this model that we can, so, and I'm an economist, so I can relate to that. But so my question, piggybacking onto that, is there a continued need for the ethanol mandate, or since 2012 have conditions changed enough, both on an economic side and on an environmental side, to justify the continuation of this mandate?
Yeah, given that, okay, this is just my personal opinion, given that the climate change is happening, we need to look for all the options that would help to minimize the emission of greenhouse gas emissions. So the very basic principle behind introducing this kind of mandate was to switch from fossil fuels to those more environmentally less polluting fuels. So given that, when it has been verified that the emissions from these ethanol, especially advanced fuels, they emit about 50% less than the conventional fossil fuel. So that definitely contributes, helps in reducing the greenhouse gas emission, and that helps to positively impact this climate change scenario. And in my opinion, this is the greatest challenge of humankind. Now, I mean, this is getting worse and worse. Every day we are seeing many floods, drought, so frequently. When I went to Nebraska in 2009, I remember that in, I think, late September, by this time, there was so much of snowfall. And I stayed there for 5-6 years. Within 5-6 years, I can visibly see that the winters are getting shorter and summer is getting longer. So given this challenge, we can look for all options. Now, certainly there are many arguments against use of biofuels also. And those were the arguments actually led to mandate waiver. Even though EPA didn't grant any mandate waiver during that drought, EPA granted mandate waiver in 2013, and recently EPA granted mandate waiver to the small refineries. So there is always, I mean, there's two kinds of lobbies. One is related with corn producer, another related with oil producers. There is always politics going on, so the mandates are waived, but in principle, the whole idea of introducing this ethanol in fuel market is to contribute to that climate change problem. So personally, I feel that it would be helpful, and given that it is governed by, it's not only the mandate that is driving the consumption of ethanol in US, because it's quite, even with considering that the energy content of ethanol is about 66% of 1 gallon of gasoline, but if you calculate the economics, it is still a cheaper alternative. So that is helpful to the consumer as well. So given all these factors, I feel that continuation of mandate is helpful.
Maybe, and we could argue about that because from an environmental standpoint, production of corn itself results in soil erosion as a row crop, atrazine, it takes gasoline to produce corn, et cetera, et cetera.
Yeah,
So
I think they did life cycle analysis. They conducted life cycle analysis from production of corn to ethanol. So they accounted all those environmental problems, all those emissions, and net emission from ethanol turned out to be less than if we just use conventional fuel. So that has been the argument. But yes, definitely there is a food security argument also. I mean,
Right.
people say that there are in many developing countries, people are dying because there's no food, and we are using corn to produce ethanol here
Exactly.
in the United States. So there are different arguments. I mean, there is always different perspective to any kind of policy.
So my semi-facetious solution is to drive a hybrid or electric, because that's what I do.
Is your car hybrid? Is your car hybrid? Oh, okay then.
I just want to add one more point to that. So maybe that is the reason why they have, if you look at that mandate chart, the proportion of corn ethanol has stayed the same, but the proportion of other advanced mandate, which is cellulosic, biodiesel, other has increased over the years. And that may be another reason why they designed the policy like that.
I think I'm going to piggyback on this one. The mandate itself is a good idea. The only problem is limiting it to bioenergy is the problem. Because alternative energy is not only bioenergy. You have solar, you have wind, you have other sources of energy that cannot compete with the food, that cannot compete with water resources, that cannot compete with other impacts. Because the issue of bioenergy is it competes not only on food, not only in meat, it competes on natural resources, competes on water, et cetera, et cetera. So I think the approach of dealing with this issue as a nexus, there is a water, energy, food nexus that really we are competing for the same resources. So there are some people should give back certain things in order to get, because we're competing. So someone is going to give up to the competition, and of course, energy will always win against food because it's driving. So I think the idea, as I'm mentioning, is great idea. The only thing is limiting it to bioenergy is the issue, because we do have other resources of alternative energy that are much far less, like as I mentioned, wind, photovoltaic, sun, harvesting the sun, also algae, waste, et cetera, et cetera. So I think this is the issue. And I guess the problem is like how to, what I like about this topic is people see the link between these three things that we are dealing with. And more than that, you can either have the health, you can have other things, natural resources, et cetera, et cetera. So for us, especially for the college, it shows that the link between all these areas that we are dealing with, food, energy, and also the market, all these things. And more importantly is you can see the importance of economics on what we do. Because if you don't put a dollar sign on what we do, it's not going to be economically viable, etc. So I think it's a great topic today. Thank you.
Thank you.
Thank you, Dr. Edu. Dr. Sunil, in one of your concluding slides, you indicated that consumers will not benefit from this and corn producers will not benefit from this. I think I'm missing something because
Yes.
corn producers should always come ahead. Their commodity is a scarcity, so that should be in demand.
Actually,
I don't understand that part.
yes. As I mentioned in those slides, what those mandate waiver does is that reduce that demand, actually, because what mandate does is that it creates artificial demand for corn because the ethanol sector wants to use that corn for ethanol production. So when that mandate waiver happens, there is a reduced demand from ethanol sector for that corn. So the implication of that is the corn price would go down compared to that mandate scenario. So when corn prices go down, definitely corn producer would not like that. And in case of consumer, what we have seen that even though the corn prices goes down with mandate waiver, and the direct beneficiary of that is the livestock producers and the processors, but I mean, there is the market structure of livestock industry. I mean, if we look at it, it's quite consolidated. There are only few players in the market. So that relief is actually not transmitted up to the retail market. And so the consumer don't get that reduced benefits from that. So that is the reason why the consumer may not like this policy.
Okay, we have time for a few more questions. Dr. Park.
Mine is more of a comment than a question. Having observed this for the last 15 to 20 years, and I was actively involved with the biofuels industry back in the early 2000s. And I remember when the mandate was put in 2007 when corn prices spiked to $7 a bushel. I just checked the prices this morning. Corn is at $3.80 today. So my comment or question is, what real impact did it have, and who were the winners and losers in this? What I remember was back in 2007, when corn prices went to $7 a bushel, farmers were buying, they were planting fence row to fence row up to $15,000 an acre for corn land. And I'm wondering at $3.80 a bushel in 2019, can these farmers still afford to pay the margins?
Exactly. What happened when that artificial demand was created, everybody started growing corn. So they started converting soybean lands to corn. So when everybody starts to grow corn, obviously there will be excess supply. So the market thought that this is the demand, the demand would keep on increasing, but that didn't happen because, as we can see there, the mandate became static after 2015. So it becomes static. So demand is there, but everybody has started growing corn. So what we are seeing is that the effect of that. So everybody started increasing their corn acres, and then prices started to tank. So that's what we are seeing right now. I mean, just like what you said, initially that went up to $7. Even with drought, it went to $7. Now, after 2013, what we have seen, I mean, it's so amazing. During 2013, compared that farm income, U.S. farm income in 2013 compared to now, is almost half. So that's a quite drastic decrease in farm income, mainly triggered by this decrease in corn prices and livestock prices. Livestock also expanded over the years. The inventory expanded, and that had effect. Now, they are again starting to decrease the supply. So this will take some time. The whole adjustment process will take some time before we see again a little bit of relief on prices.
Okay, any other question?
Oh, thank you for your presentation, please. I have one question for the fundamental question in
Sure.
your model. When you're using the matrix form is XA equal B,
Yes.
but basically so when you estimate the parameters, but is the matrix size, you use setup is the 43 by 43,
Yeah,
43 by 1 equal B is 43 by 1.
So
Yeah, but my question is when you're running the kind of model, basically is the input size is relatively small, 45 by 43. So that
Yeah.
means is when you apply so many model, is efficiency is we cannot guarantee.
Yeah.
So why you setup is like that size?
Yeah.
I need to know that.
Yeah,
the reason.
because that size is decided by how many commodities we are trying to analyze. So if we look at there, we had 8 commodities. So depending on, so it's all composed of elasticity. So depending on, we specify demand and supply equations. So that turned out to be 43 by 43 metrics. But if I include trade and other commodities, like I said, this is a partial equilibrium model. We are limited. We are not saying that in reality, to be very honest, those factors would also change. But our assumption in this model is that we are assuming, just to avoid complication, we are assuming that those factors remain constant. So if we include that, all those factors, definitely the metric size would be bigger, much bigger. And it is those elasticities. It's econometrically. I mean, I myself didn't estimate. It's from other economic studies. I collected those elasticity coefficients for those metrics.
Okay, my question is, Dr. Fair said there are other sources of alternative energy, more environmentally friendly, but the focus is on biofuels. Why is that?
I mean, always there's economics and politics are always together, right? That's why they have school of like economics and politics. Probably that would be the reason, because there is always different interest groups involved in biofuels. Like corn-producing states, they have different interests versus oil-producing states. So always there is always this focus. So whenever we have that kind of thing, that is the one highlighted. Like Dr. Faris said, definitely we should look for other options like solar energy, right? Other clean energy. Definitely those should be also in focus, but given the politics, I mean, that is really highlighted. And that's why, and they have, in my opinion, I think they have quite a political power or political capital that can highlight their issues. That's why we see frequently, we saw recently some mandate waivers.
Thank you, Dr. Sunil. You mentioned there is a market for a RIN credit,
Yes.
and it's fluctuate. So if there is any studies or background about the impact of the drought on the RIN credit itself and how it's gonna affect the, the demand and the model here.
Yeah, actually, we didn't look at how this will impact the RIN credit market. Definitely, if, let's say, as per our analysis, if, let's say, EPA says that everybody has to exhaust their RIN credit, definitely there will be more demand for RIN credit because everybody wants to, they mean that there will be more demand for RIN credits, so that spikes. Actually, I think a few years ago, the RIN credit price really spiked. The reason for that was there is this thing called blend wall. So in United States, as the mandate works is that you have to mix certain volume of ethanol with gasoline. So the gasoline consumption has been static over the year. So it has been like 140 to 150 gallons, a billion gallons. So because of that, they cannot mix more of ethanol. And why that is the case is that because right now the infrastructure, the car that is produced, or the refineries we have, that allows about only 10% of blending. So if you want to blend more, as per the mandate, then your infrastructure needs to be changed. So what that led is the spike in price in RIN credit, because now everybody, since they cannot fulfill their allotted mandate, they started buying RIN credit from the market. So that spiked the RIN credit prices. But in this study, we didn't look at how this drought would affect the RIN credit. I think that would be an interesting issue to look at.
Okay, with that, I want us to thank Sunil for such an interesting presentation. Hopefully we'll emulate Gerald and all get a hybrid car, or better still, maybe a Tesla, to reduce greenhouse emission. So let's give him a round of applause.
Thank you very much.
Okay, for next week, we have another interesting presentation. And this is going to be given by Dr. Thomas Goyen, who is the director of